Oh my god, I don't know how to answer these questions. Hello Norman, can you help me with these limits questions?
Sure.
Yeah, what's up Daniel? Yeah, I'm doing limits as well. I'm having some problems also. Yeah, I think we can come down to ATV and discuss about this topic. Yeah, I need help too. Let's do this, Joe.
Tak boleh jawab ni. Tanya Daniel lah. Hello Daniel. Ni dah siap ketuk limit. Aku tak boleh jawab lah. Tak boleh ke? Kita jumpa bilik TV C1. Okay. Aku tunggu bawah.
Hey, how are we going to do this? Twitter 20.
Quite difficult.
That's the question I asked you.
I also don't know how to answer this question because it's pretty hard.
I know a bit of it, but I'm not really sure about steps.
I think we're gonna need somebody that is good at this topic.
Who should we call?
I think we should call Naavin.
Yo, hey Naavin. Wait, did he pick up yet? Okay, yo, hey Naavin. Yeah, we really need some help. Like, is it possible if we come down to BTV C1 just to help us out with question 20 for maths? I think if we discuss more about this, I think we are able to do it. Yeah, alright, see you there. Bye.
Sure.
Hi Norman. You need help with limits? I'll be on my way. Let me go to my room and take my books. I'll be back soon. Alright, see you in Bilik TV. Okay, so you guys have question with problem 20, am I right?
Yeah.
Okay, so this is how we start. So question 20 says that fx has three function paths, which is x squared plus 3b and ax plus 2. The first function will be x is less than 1, x equals to 1, and x is more than 1. So then the question says, is continuous on the interval bracket negative infinity bracket, find the values of a and b and sketch the graph of f. So what we're going to start is, we know from here that we can say that fx is b, x equals to 1. So we can automatically say that f1 equals to b.
Oh, wow. Amazing.
Okay, so do you understand now? So we just take the one which is quite simple. We see the second equation, so this is the first function, the second function, and this is the third function. The second function is easy, is b. So when we take b, we already know that f1 is b. So next, we can say that this function will be limit x to 1 on the left side, because it says less than 1, so we look from the left side. This function, however, will say that limit is x to 1 from the right side, because it's more than 1. So we will move from the right to 1. So here, x squared plus 3. So let's write this down. Limit x goes to 1 from the left, which is x squared plus 3. So we can sub the x to 1 here. So we will get 1 squared plus 3, which equals to 4. So now we can say that the fx here will equals to 4, which is our first function. The second function we already know is b. Or we can say, well, yeah, it's b. So the third function, which is this one, the limit we will set as x is going to 1 from the right, which will be ax plus 2. So here we can sub ax as 1, so you get a1 plus 2, so you have a plus 2. So fx, which is this one, the function of fx, we already connect here, we can say that fx from the first equation, the first function equals to 4. So when we sub in back here, we will say 4 equals to a plus 2. Like normal maths, a will get minus 2. We move the 2 to the left and we will get 2. So we can say that from here we can say that the limit of x going to 1 from the left equals to the limit of x going to 1 from the right. So how we can say that the limit of x 1 minus 2 from the left equals to limit of x approaching to 1 from the right is because from the function here we can say that first fx and second fx and the third fx are in a straight line because this one equals to 1, this one is on the same line, and we can say that it equals to 4, and here we can also say equals to 4 because they are on the same line, as their inequalities come here, which is x less than 1, x equals to 1 and x more than 1. So therefore we can assume we can justify that the limit is the same. So which shows that the second function, the limit would also be 4.
So Naavin, assuming that equation 1 is 1, equation 2 is 2, and 3 is 3. So are we able to compare it like equation 1 to 3, 3 to 2, or can we compare another way like 2 to 3, 3 to 1, or 1 to 2?
Yes.
Yeah, any other way we can do that.
Yes, we can compare due to that all the three functions, their limit is equal.
I see.
So when all the limits are the same, we can compare. Doesn't matter 1 to 2, 1 to 3, 2 to 3, 2 to 1, or 3 to 1, 3 to 2. So since all the limits are the same, we can compare them to each other. So hence we can justify that all the three functions have the exact same limit due to their given values here, which is x is less than 1, x equals to 1, and x more than 1. Is 4. So our fx actually which equals to b will be 4 equals to b, or b equals to 4. Okay, so since we've got our values here, so let's move these functions into a real function where we don't use the unknowns anymore. So the first function, fx equals to x squared plus 3. The second function, fx equals to 4, because we found out that b equals to 4. And the third function, fx 2x, we get these two because we found a equals to 2 from here. So we have to connect the questions with the one we found before, which is what the first question says, find the values of a and b. So we can state that a equals to 2 and b equals to 4. That's the first question now. So next they said, hence sketch the graph of f. So here we're going to sketch a graph. So we draw the Cartesian plane. So the first function we have is x squared plus 3. So 3 shows that it the line of intersection is at y equals to 3 here, because we can say that y equals to 3, like if I'm going to bring this equation here, fx equals to x squared plus 3. So I want to find y. So y equals to x squared plus 3. So when we want to find the y-intersect, x equals to 0. So y equals to 0 plus 3, y equals to 3. So the y-intersection for the first function will be 3. so we will get 3 here, and it's a quadratic graph, so you will get a smiley graph. The first graph here will be like this. So that's okay. Now we move to the second function, which is fx equals to 4. I want to know the intersect for this graph, so I'm going to sub fx as y. So when I sub fx as y, y equals to 4. So I'm going to draft the graph here. So this will be my y, and this will be my x. 1, 2, 3, 4. If this was 4, this will be my line for the second function. So next we move on to the third function, which will be fx equals to 2x plus 2. So I want to find the y-intercept now. So we're going to sub this into y. So y equals to 2x plus 2. When we have y-intercept, x equals to 0. So y equals to 2. How about the x-intercept? If the x-intercept, y equals to 0. As fx equals to 0, 0 equals to 2x plus 2. So I want to find x here. I'm going to move this here. Negative 2 equals to 2x. I'm going to find x equals to negative 1. So now I know that the graph of fx, the third function, intersects at y at 2 and x at negative 1. So let's sketch the graph. This is 0, this is y, this is x, so this is negative 1, this is 1, and this is 2. So if we draw the graph, y and 2, negative 1, this is how the third graph will be. Okay, so now we'll come back to all the 3 graphs again. So this was the graph for fx. We haven't yet see the limit they gave us, which is x is less than 1. So if this was 1 and this was 2, so our limit was x less than 1. So this is the line. So this is where the circle will be. The remaining line here, we will erase it. So this is how the first graph is supposed to look like. The second graph, however, which is the limit was given to us was x equals to 1. So if this was 1, and this will be the line for us, we'll have a black dot. This will be the black dot here, which indicates x equals to 1.
The black dot is there.
Okay, the black dot indicates that x equals to 1. We use a round follow dot to show that x is less than 1. So now we move to the third graph, which says the limit given to us was x is more than 1. So if it was more than 1, if this was 1 and this was 2, if I'm going to do this, if this was the line for us, this is our limit starts. We'll draw 0 here and we'll erase the line here. So when we are going to combine all the 3 graphs later, we are just going to draw this part of the graph, nothing more. Okay, now we are going to combine all the 3 graphs together. We will draw it nicely. So we will label this as the y-axis and the x-axis. So if we see in the one before, we show that the first graph is supposed to be like this and stops at 1. So we want to do that. We will say this was 3 and this is 1. So this is our line. We're going to draw a smiley graph and we are going to stop here. So this is the first graph of the function completed. So the second graph will be y equals to 4 and x equals to 1. So x equals to 1 and y equals to 4. So if this was 4, so our line will be here. So this this indicates that this is where the point will meet with the other graph. So this straight line, we're going to make it into a dotted line. So let me exit that. So we're going to show that this is a dotted line. The line starts from here. So this is the line. So now the third function, which is just a straight line after 1, a linear graph. So this is 1 and this is the one after 1, so we're going to go up. And yet it is more than 1, so we give it a hollow circle. So that is question 20. So hence sketch the graph of f, we have sketched the graph of f. So Daniel, do you understand so far?
I think there's a mistake, a slight mistake. When at the previous graph, there's a darkened circle, which is here, but I think this should be a darkened circle because x is equal to 1.
Yes, you are right. It should be a darkened circle. So please bear in mind, this might cost us marks. Making a dark circle will save us marks. Norman, do you have any questions? Do you understand so far?
Yes, I understand everything so far.
How about you, Arif? Are you okay with the explanation?
I think you have left something. You forgot to name the graph, which is fx.
Yes, you are right. We are supposed to name the graph as fx. So this concludes the question 20, where all the questions have been answered. The sketch the graph of f, this is the graph of f. So full marks in exam. Thank you.